This problem asks to find the velocity of a skydiver 4.5 seconds after exiting an airplane. It also asks how far they will fall during this time. So let's start, as we always do, by drawing a picture. I'm going to draw my skydiver here. All right, I don't have to be very artistic here, but they're going to start here. What can we assume about when they leave the plane? The problem does not tell you they jump up or down, so let's make an assumption that they start with no velocity. Right? And then they start falling, right? They start falling down, and later, skydiver is further down. Maybe they haven't pulled their chute yet. We've had 4 seconds of time of 4.5 seconds. And now at this point, they do have velocity, right? So we represent velocity by drawing an arrow, and there is going to be some final velocity, which we don't know at this point. Let's continue here. Make sure we have our direction figured out. So in general, we're going to define the positive direction as upward. So we know that this final velocity is going to be a negative value. It's a downward arrow. But how did we gain that velocity? Well, we must have experienced a push or a pull, right, that accelerates this skydiver. Well, what is the acceleration? It's gravity. So I'm going to draw another down arrow to represent the acceleration due to gravity. And as we know, gravity on Earth is fairly constant near the surface of the Earth, and it's going to be negative 9.8 meters per second squared is the acceleration due to gravity. What about its position? Well, let's say he starts right here. Let's call his initial position, and let's just define that as 0, which means we're also going to have a final position at this point, right? So ultimately, we need to find those two pieces. For the sake of getting some practice with graphing, let's go ahead and draw a position time and a velocity time graph. All right, so we have time on this axis. We're going to put position here. We got positive position. And we have velocity here, positive velocity. And let's plot where this diver is located. Well, they're certainly above the ground. They're going to be up here. Are they moving yet? No. So I'm going to put a flat line to indicate there is no slope. And if there's no slope and no velocity, then I can put a data point right here. What about later? Well, they're going to be closer to the ground. 4.5 seconds later, as time moves to the right on this t-axis, I can plot a data point that is lower than where I was. Has he gotten all the way to the ground? Probably not in 4.5 seconds. Wouldn't be a very fun skydive. So I'm not putting him all the way down. What I do know is this skydiver is now moving downward, which would be the negative direction, and it's certainly faster than 0. So I'm going to have a negative slope, and we start to see that we should get part of this kind of parabola shape. And a negative slope is a negative velocity. So I can plot a data point that happens at the same time below 0, right, in the negative direction of velocity. And we know that that velocity, because it's gravity, is changing at a constant rate. The slope on this graph is the acceleration, and it would have to be negative 9.8 meters per second squared, right? So ultimately, again, got a good position time graph. We have two equations to model the motion for any object that is moving along a path and accelerating. We have their position, x final, is 1/2 at squared plus v initial t plus x initial. And we have their velocity final as at plus v initial. Let's call this equation 1 and this equation 2. Right? And so what we need to do is we're trying to find two pieces. Now, I kind of have a table within my drawing. I have all my variables listed, so this might be good enough. But I like setting up what I call an ATVX table. And it's just a way to organize the variables we have. Right? You have an acceleration, and it is downward at 9.8 meters per second squared. That's gravity. You have a time. They give you that as 4.5 seconds. You have an initial velocity of 0 meters per second. You have a final velocity that all we know about it right now is it's going to be negative. So I'm going to put a negative there, right? We have an arrow downward. It should be a downward answer, but I'm trying to find that speed. They ask for the velocity of the diver after they exit the plane. I have an initial position. We actually have an altitude. You might actually know the altitude. If they told it to you, you could write that value. But since we don't know, we're going to get 0 meters. And we're actually going to find a final position. However, if we set the plane at 0, they're actually going to have a negative answer as the final position, which is kind of interesting. They're actually above the ground, so this can be a little bit tricky. We'll talk about some other things you can do with this problem, maybe to streamline things. Nonetheless, this is a good table. I'm going to mark the things that I have, right? So I'm going to put question marks over what I don't have. I don't have V final, and I don't have X final, right? But I do have everything else. I have A, T, V initial, X initial. I basically have everything I need, which means if I want the things in this table, if I want V final and I want X final, I can plug and chug, right? So for part 1, let's find V final. V final is using equation 2. Which says that the final velocity is equal to A times T plus V initial. And I can just plug in negative 9.8 meters per second squared. I'll put the units here, but you don't have to as long as everything's in meters and seconds. 4.5 seconds plus my initial velocity of 0 meters per second. Pretty simple math right here. We're going to get a final velocity. Lo and behold, it is negative. I expect it to be negative. And it's 9.8 times 4.5. Which makes sense, right? I'm adding 9.8 meters per second every second. If it was 4 seconds, it would be 9.8 times 4. So I expect something in this ballpark. I had 44.1, and that's a velocity. Well, look at my units. I have seconds canceling with one of those seconds, which leaves us in meters per second. In fact, that is a velocity unit, right? So we have our first answer of 44.1 meters per second. What does negative mean, though? There's nothing about this problem that tells you anything about positive or negative. The negative came because we decided to call up positive. So to say the answer is negative is kind of confusing. So what I'm really going to say, if I want to give an answer, is I'm going to say 44.1 meters per second downward, because that's what negative means. This would be the best way to describe the answer to this problem for part A. Now, part B, how far will they travel? Right? Well, if I know X final, I can find how far. So we're going to find X final using the first equation, using equation 1. And since we have everything, I can just plug in X final is 1/2 AT squared plus V initial T plus X initial. And I'm just going to put in the values I have. I have 1/2 times the acceleration, negative 9.8. My time is 4.5, and we squared the time. My initial velocity is 0 times 4.5. Well, 0 times anything is 0. I decided to call my initial position 0. Right, so that goes away. So really, all I need to do is plug in those values. And there's a couple ways to put in your calculator. You can type in 1/2 as a fraction, and then times 9.8, and it's negative 9, but I'll put it exactly in there, times, and then 4.5, and there's a square button here. 4.5 is the same as multiplying it by itself, but that should work, and I get an answer here of negative 99.2 as my final position. Negative 99.2 meters. Now, we could put that in another way. We could put that in as 0.5 times 9.8 times 4.5 squared, and we should get the same answer, except it'd be positive. Oh, well, I know that is negative, and I can put a negative in there. My calculator's kind of stupid. But nonetheless, I get an answer when I plug in of negative 99.2 meters. So how far do they travel? You can't travel. This is a distance, right? How far would be a distance? So what's the distance they traveled, right? Well, then they fell. If they started at 0 and went to negative 99, then they fell 99.2 meters, right? We don't need that negative sign. Negative just is what we expected from the way we drew it. We have to interpret our answer. Give an answer that's reasonable based on how the question is asked. So again, a good example where we can draw a little picture. We got to be careful of direction, set up an ATVX table, and then simply plug in and get answers.